In this video, I'm going to perform the Gold Belt Kata in Python. I have the project open here in Visual Studio Code along with the README file. Let's look through the 10 steps really quickly and we'll dive in. So step one, we're going to create a test to demonstrate the as-is functionality. It will not pass, at least it won't when I write the code. Step two, we're going to refactor just enough to get the test to pass. So these first two steps are going to be quite a bit of work just to get there. Then from there, we're going to switch gears. Step three, we're going to refactor the code to add branching points or forking logic so that we can start thinking about how we want the future test to look. Then we'll create a test that shows the ideal state. Then we'll make that new test pass, and then we'll refactor. So that'll be a good chunk of code there, a good chunk of time. These last four steps are going to go much more quickly. We'll add a failing test to represent a bug. We'll fix the bug in the code. We'll make sure everything passes, and then we'll refactor once again. So that's the idea. That's the flow. So we'll start off. I do need to run a couple of commands real fast. So we'll pip env shell and pip env install, and I'll just install with dev just to make sure we get all the dependencies. Let's go ahead and create our test folder while that's running. Well, that went fast. We'll create our file. So we'll say this is transaction loading test.py. Now I could use unit test or I could use py test. It's totally up to you. I'm going to use py test. I think the syntax is a little easier and simpler to write. It does mean I need to install a package, so let's go ahead and do that really quickly. We'll say def test transaction loading, and let's just call this successful system test. Let's just pass and make sure. Actually, while I have this open, let's select our interpreter. I want the Gold Belt Kata one that I just created. All right, well, it's not happy about that. Let's see if we can get configure the test to run. I'll use the test runner. There we go, and run. All right, perfect. So we get a pass. I do have my test up and running. So let's start talking through what we need to test here. So it's going to be in main. So I've got the main module inside a main, or main package with the main module, and in that there's going to be a main method. Oh, that is silly. All right, so we're going to import main. We want to call into the main method. That's going to be our entry point for running everything. So we'll say from main.main import main. Let's just call into main, and we're going to run our test. If it passes, then we need to figure out how to make it fail. If it fails, then we've already got a starting point. So it does pass. Now, the reason it's passing is that we have a global accept, a global catch that's going to catch any error that's coming out, and we'll simply log that off to the console so the user can see that. So let's talk through our test real fast. What do we need to do? There are two dependencies. There's the database and there's the file system. So we need to initialize or reset the database, make sure that's in a clean state. And then we're going to use that particular database for our code. The file system, we need to copy the file out somewhere that we can use it. And then we also want to tell the main code, use this file path instead of whatever it is you were going to use. We want to reset those when we're done. And then also we want to assert that we got the records in the database. So we'll retrieve the records from the database, make sure that there are the 3 that we expect from the example file 1. And then we'll also make sure that the file was deleted. So quite a bit going on here. Let's start creating some code here that will perform that for us. So we'll say reset database. We'll just call a function to do that. Then we'll also create the CSV file path. This is going to copy the file. So we'll say copy example file 1, and then we'll get the path. Now that we've got those, we need to tell the main functionality we want to use this database that I got set up and the file that I have set up. There's a couple different ways to do this. I've got a video that talks through that. The two different ways, I could create an original. So I could create an original CSV file path, original host, original username, original password, or I could use an override. Either way works. I'm going to use the override in this particular case, but you could certainly go with the original paths and the original host and that approach as well. So we'll say override connection info, and we're going to pass our local database host, local database username, and local database password. And then finally, we'll override CSV file path to be our CSV file path that we created as a part of copy example file 1. Now that we've got those, I do need to make sure we reset those back for the next test. So let's put this in a try finally. And we will say reset connection info and reset CSV file path. And then finally, we need to make sure that we have the records. So let's retrieve those records. So we'll say transactions is retrieve transactions from database. And let's assert that the length of transactions is 3. And then we also want to make sure that the file was deleted. So let's assert, and to do that, we'll need to import OS. So we'll insert os.path.exists, CSV file path equals false. So here's our test basically set up. This is the test that we're going to run through. It's got quite a bit going on. Most of these functions and objects I want to do inside the test file. I want to do as little as possible inside the main module, the main.py file, as possible. So I want to do most of this here. So let's go ahead and create some of this real fast. We'll do test methods. We're going to need constants, and we're going to need helper functions. So let's start with our helper functions. Reset database, def reset database. This will return nothing. And we're just going to pass for now where we can. Let's do copy example file 1. This is going to return a string that's going to be the path. We'll just return none for the moment. Override connection info and override CSV file path along with the reset versions. These are going to be in main, so I'm going to ignore those for now, but I do need my constants here. So we'll say local database host, local database username, and local database password. All right, so those are looking good. Now we need retrieve transactions from database. So this will return some sort of list. Let's look in main. I think there's a class, there's a transaction class that just takes the values. We could use that. So let's do that. Let's say this is a list of transaction. So we'll need to import transaction. Excellent. And again, we'll just return none for the moment. All right, we've done everything that I think we can do inside the test file. These last functions are going to need to be in the main.py file. So let's go and create those. I'll do this just above the main method. And this is going to be the host, username, and password. This does not return anything. We'll just pass for the moment. Then CSV file path, we'll do the same thing. Pass. And then reset, we'll do the same thing on these. Reset CSV file path. And finally, reset connection info. All right, we won't implement these quite yet. I'm just trying to get this to a point where I can run the test, see if we can get to a failure. If nothing else, I'm hoping for a failure in one of these two assertions. All right, so we do need to import these. Let's do that very quickly. All right, so we've got everything imported in. Yeah, that looks pretty good. Let's go ahead and run our test. All right, so we do have a failure, and the failure is happening at the assertion. And so it's not actually getting to the assertion itself. Transactions is coming back null, and so we can't call length on that, which makes sense. So that's in good shape. I could return just an array, but I actually want to see when we do something a little different, when we actually get that to work. So this looks pretty good. So let's head back to our README file, and that is step 1. For step 2, we want to refactor just enough to get this test to pass. Again, we're going to start off in our test. I want to do as much as I can inside the test file and wait till the last possible moment to change anything in the production code. Again, there's a lot of different things that can go wrong when we change production code, so I want to avoid that, and I want to do it as late as possible. If there's anything I can do inside the test file, I'd rather do that first. So let's start off in our test file. There are a few different methods that we need to implement. I'll just start off from the top and then go down. That way we can see as we're making progress. So reset database, what we really want to do here, there is a create DB module here that we can call into that's got a main function here, so another main. But in here, these are hard-coded in. I don't want to do that. I want the test to specify these. So let's pass these in. We will use those values instead. So now these values should not be used. Let's comment these out. So now I can call into main. Oh, I see. If I've got the start up, I'll leave these in then. We'll say host, user, password. All right, so if we do actually execute this straight out, it'll do what we did before. Otherwise, I can pass them in. So this looks pretty good. Let's go ahead and import this in now. So from main.createDB, we'll import main, and I'm going to alias this as createDB. So we'll simply call createDB, and we'll pass it the local database host, local database username, and local database password. Now we are going to need these values. So we'll say localhost, username is root, and my super secret password. All right, so that looks pretty good. Let's run the test real fast and see if we have a new error or the same error. I'm hoping for the same error. A new error just means I did something wrong. And we have the same error. Excellent. So we are expecting that the database did actually get created, dropped, and recreated successfully. Now let's move on to the copy example file 1. We need to copy the example file 1 from the example files folder into the directory where we need it. So in order to do that, we need to get the path to it. So let's say source file path equals, and this will be from our current directory. I'm going to go back one. I don't remember exactly where this folder path is. I think that we start from the test folder, but I'm not sure. So we're going to run this and we're going to verify, and then we'll change as we need to. So you can use this approach anytime you're not quite sure what the file path is for which you're looking. So go back one, we'll say example files, and then example file 1.csv. Our destination file path is going to be, again, I'll say back one, and then let's create a test data folder, and let's put it there. And I'm going to create this as the same name as main.py, which is accounts.csv. I don't have to do that, but I want to keep consistent with what's happening in the production code. So I'll just rename it from example file 1 to accounts.csv. And then from here, we can copy. I believe we want the shutil package, and then shutil dot, copy file, source, destination. Now, before we do that, let's verify this. I want to say source file path equals os dot, I think it's path dot absolute path. So I'm going to do this, and I'm going to set a breakpoint here, and I'm going to debug the test so I can see what the file path looks like. Source file path. Okay, so C, code delete me, Gold Belt exercises, don't move on me. Gold Belt exercises, Python, src. Okay, example files. It did not include the Gold Belt Kata folder between source and example files. Okay, so I actually don't want to go back a folder. I'm just going to keep the current folder. So now let's debug this again. Source file path. Gold Belt Kata source, Gold Belt Kata example files. That looks correct. All right, so now let's just stop this and run our test. We get a failure pretty quickly. And what it's basically saying here is, where is it? So the copy example file 1. Where's your error message? Source, destination, copy. File not found error. No such file or directory, test data /accounts. What it's actually complaining about is the folder path. So the test data folder path does not exist here. So I could create it, but I want the code to be able to do this. So what we'll do instead, let's create a folder path. So we'll say test data folder path equals test data. So we'll take that part of it out of this path, and we'll just add that on. Now what we need to do, and I'm going to get rid of the absolute path, we need to make sure that folder is created. So if it doesn't exist, so if not os.path.exists test data folder path, then what we're going to do is we're going to create it. So we'll say os.makedir test data folder path. So we'll create that if we need to, and then copy the file out. All right, so that looks pretty good. Let's go and run our test now. All right, so the long time is promising. I think it's actually trying to connect to the database. And it is, so that's working. Let's run it again and make sure we don't have a copy file problem. It failed right away. And it failed really quickly. All right, I think we're in good shape, at least for now. I was actually expecting to get an error because copy file, I thought there was a copy to make sure that it overwrites. And there is. But let's keep it. If it's working, I think it's working. So I think we're in good shape. All right, so there's our copy file. We may have to come back to it if it is causing a problem. The last one is the retrieve transactions from the database. So we need to implement this. So here, I'm going to basically pull from main. We were connecting in with MySQL, and we were just creating our connection to the database. And then from there, we're going to execute the query that we want. So let's go ahead and do that code real fast. So we'll say with as connection. So we're going to use the entry context. We do need to import MySQL. So there's our connection. And now we also need to change these to be local database host, local database username, local database password. And then the database itself, I believe there's a constant. Yes, so I'm going to just use this database constant here. Excellent. So there's our connection. Now that we've got that, we need to create our cursor. So with connection.cursor. And there is one thing I want to do here, which is, I think it's dictionary equals, and I want that to be true. I want to pull back the data as a dictionary. That way it's a little easier to deal with. If I don't do that, it comes back as a tuple or tuple, depending on how you pronounce it. I've always heard it as tuple. Tuples you're going to index with the column number, the ordinal, the index of the column, 0, 1, 2, 3, 4. The dictionary, we can access the columns by name. That's going to be a little easier to read. So say as cursor. And then from here, we simply say cursor.execute, and we want select star. And let me head back to create DB. So the table name is transactions plural. And let me just confirm that is the case in the main. It is. Okay, so we have a plural name. I'm not a fan of plural table names, but sometimes you do run into that. So cursor execute select star from transactions. And now we'll fetch all those records. Now we can create our list. So we'll say our transactions is a new list. And then for each record in records, sorry, Java syntax. For each record in records, we are going to create a transaction. So we'll say append a new transaction object, and it needs the different values. So we can just say record bracket date, and I think these are just, yeah, date, account number, amount, and transaction type. Perfect. So date, account number, amount, and transaction type. Excellent. And then finally, we will return our transactions. All right, that looks pretty good. Let's run our test again. Let's see if I've got an issue. Still taking a few seconds. And let's see what our error is. Excellent. So our error is actually the assertion error. It's saying 0 does not equal 3. So it did actually pull from the database. It executed without an error. So we're in pretty good shape here. Let's pause this for a moment. We've done everything that we can do inside this file. So now we're ready to actually implement the functionality in main that overrides. So let's start with our override methods first. So these methods, so the reset, let's do the reset. So reset is simply going to call override connection info, and we'll just pass none in for these values. I could also just not pass the values, but I'll just pass none. And then override CSV file path. I like passing none because it's a little more explicit. It says what we are intending to do explicitly instead of just calling a method without arguments. Now these, what we're going to do is we're going to need to set the host. Let's see. So we'll say host override equals host. Username override equals username. Password override equals password. And then finally CSV file path override equals file path. So simply hold on to these values. Now we do need to declare these so that we can use them. Global fields. So this would be host override equals, and let's say this is a string equals none. Username override is a string equals none. Password override string equals none. And then finally, CSV file path override is a string and it is none. So we're going to default these to none. So let's go back down and look where we're using those again. You'll notice that Visual Studio Code is telling us, hey, you're not using these. So when you retrieve a value from a global field or a global variable, you don't need to do anything. But if you're going to change it, we have to declare it with the global keyword. So we're going to say I'm declaring host override as the global scope. So I do these on all of these variables. Little Python gotcha. All right, so now we've got those. We are setting those values correctly. Now we're ready to use them. So far we haven't really changed the production code. We've added some code inside the production module, but we haven't actually changed functionality. We're now ready to do that. So let's look and see first off where host is used. So we'll match case. So host is only used in one place along with user and password. So that makes it nice. I'm going to format this so these are each on a separate line. It's going to be a little easier to deal with, because we're going to add some code in here that's going to be a little long, and I don't want the line to be too terribly long for the code. So here what we want to do is, instead of host, if there is the overridden value, we want to use that instead. So I'll use the ternary in Python. What we'll do is say we'll use host override if host override is not null, or is not none. Otherwise, we'll use host. So we'll do that on all three of these. Username override. Else, and then password override. Same thing if password override is not null. otherwise password. So that basically sets everything up for the host. Now, CSV file path is used in a couple of places here. So here's the declaration and then 2 places. So the first thing I want to do is get that into a single place. So we'll say, we'll create a variable called CSV file path. This will equal CSV file path from the constant. And now we will simply replace those with the variable. Now that we've got that, now I can use my ternary. So we'll say CSV file path override if CSV file path override is not none, else CSV file path. All right, everything's set up. Let's run our test, see if we have a problem. Okay, we do have a problem. Let's see what we've got going on. So it's saying 0 transactions, and we had 3. All right, let's see what I've got going wrong here. Let's do a break, and let's see if maybe I did something incorrectly. So let's debug in. Okay, so CSV file path is not correct. CSV file path override is none. All right, so our overrides are not coming in. Let's see if we can figure out why that is. So override CSV file path, we're giving it the file path that we got. And we go into here, we're setting CSV file path override to file path. Do I have to declare these as well? I don't think I have to do that. Let's test this out though, just to make sure. Nope. Yeah, CSV file path override is coming back as null. All right, so let's figure out what did I do here. So here's file path. Let's set a breakpoint here as well. Okay, so we are overriding. File path is not. Ah, did I forget? I think this is a silly thing. So let's head back to our test. Yes. So copy example file. I'm not returning an object, so we'll simply return the destination file path. All right, let's try this again. Let's just run the test. And it passes straight away. Excellent, and that's why we test. All right, so we do have this running. It is actually creating records in the database. It's pulling from the file, which we could tell because I had a problem there. So this basically gets the test to pass. Let's head back to the README. We refactored just enough. So now let's go ahead and check into version control. So let me reveal in Folder Explorer, reveal in File Explorer. Let's go up, and I'm going to copy this path. We're going to open this in Git Extensions. You can use whichever Git tool you want to use. It does not matter to me. So let's open that path. And let's commit. So now we have created a passing system test for the transaction loading functionality. Let's go and commit that. This would actually be good enough to push if we had a central repo because everything's working. The test is passing and we have step 2 working as we intended. For step 3, we want to add branching points or forking logic inside our code. So let's talk about what we want to do here and then we'll dive into the code. There are 2 dependencies we might want to abstract away, the database and the file. So let's talk about those independently and ask ourselves, why might we want to do that? So let's start with the database. Why would you want to abstract the database and test it like an in-memory database or something else? The primary driver of that is whether or not your team owns the database code and the infrastructure for it. If your team owns the schema definitions, the object definitions, the views, the stored procedures, all of that, and you deploy that with your application, you may not want to abstract from the database. That may be more trouble than it's worth. Instead, you can simply create a local database because your team owns it. You're not worried about somebody else changing that on you. You own all of that. And so in that case, I probably would not abstract away the database. However, if another team does own it, if they're responsible for the schema changes, they may be able to introduce a permissions problem or a schema change that might break your functionality. In that case, I do recommend creating an abstraction layer between yourself and that database. That allows you to test some of those things and make sure your application handles those conditions correctly. So that's the idea there. So for this particular exercise, we're going to pretend like somebody else controls the schema because I do want to use a pattern to show you how to do the abstraction with the database. So we are going to pretend like some other team owns that so we can abstract the database from our code. We'll create a branching point there. So let's switch gears and talk about the file now. Why would you want to abstract yourself away from the file access? Well, the simple answer is you always do, because you can always run into permissions problems on files, locking problems on files, files getting deleted or overwritten halfway through your read. So there's lots of reasons why the file system can go horribly wrong. So because of that, I recommend abstracting and creating some in-memory provider or stream-based provider, something along those lines. The reason for that is doing that is going to be a lot easier in your test code to simulate a permissions problem or a locking problem, rather than trying to set up the conditions with the test that generates those conditions. Let's say, for example, you wanted to generate a file permissions problem in a test. So the test account needs to create the file, and then it needs to remove the permissions from the account running the test so it can't read it. But in order to do that, when you do that, you're going to need to make sure the file gets deleted afterwards. But if you don't have permissions, then you can't actually delete it, and you can't set the permissions back to what it was. So it gets to be a nightmare. You could set up multiple accounts, but that starts to change how we deal with things inside the code. So effectively, just a simple thing like file permissions problem starts to break your brain. So those are the reasons why you might want to refactor or abstract away those dependencies. So we're going to do both. Looking at the database, I'm going to introduce a facade pattern. Now, normally I would probably use a strategy pattern on both, but I want to show you how you can use a facade pattern for one of these dependencies, and you could do it for either. So I'll introduce a facade pattern for the database. I'll use a strategy pattern for the file access. You don't have to use either pattern. There's lots of ways to deal with these dependencies, lots of ways to create forking logic. But since we're learning about facade and strategy as a part of the Gold Belt, I want to use those so you can see them in action. So that's our plan. We're going to create branching points. We'll show that this still passes. So from here, we're going to be in the actual main code, in the production code. We want to create our branching points. So starting off, we'll do the database first. So this is going to be the insert transactions into database. This is where we're using that logic. And this happens to call into connect to MySQL. So in this particular case, what I want to do is I'm going to inline this because I want to move this around. So this connect to MySQL is only called in this one place. So I'm going to inline this instead of calling a separate function. And then my create, we are going to get rid of this function altogether. So now that we've got that inlined, our facade, what we need to do is we need to create an object that will hide the MySQL side of things. So we'll hide this code, we'll hide this code. This code will stay, but we'll hide this code, and then we'll hide all this code. So that's the idea of what we want to do, is we want to basically hide all of this implementation. So let's run through this really quickly. Effectively, what we want to do is create some facade. I'm going to call it a database. Seems like a reasonable enough name. So we'll create a new database, and we will pass to it the host, the user, the password, and the database. So that's going to be the connection information for connecting to the database. Now that we have that, what we want to do is say for transaction in transactions, we're going to call database. This will be insert transaction, and we'll pass it the transaction. And then when all that's done, we need to dispose. So for the disposal, I'll use the context manager. So we'll turn this into a with statement. So with as database, and then that will then, at the end of it, clean it up. So that will make our code very, very, very simple. Oh, I don't know what that was. All right. So now that we've got that, let's create a couple lines. We're going to end up pulling all of this code out of here. This is what our new code is going to look like. So we need a database file, database object. I'm going to create a new file. I'm going to just call it data.py. And in here, we'll create our class database. Now we need to import that. And now we need a constructor that takes the host, user, password, and database. And inside this, what we basically want to do is I want to pull in the connect. So I'm just going to go ahead and connect straight inside the constructor. So we'll say self.connection equals MySQL connector.connect. Let's import this in. Oh, I do need self. Okay, host, username, password, and database name. All right, so now we've got our connection. So let's head back to our code. So So that code goes away. Now we need our cursor and then our execution. Now this is all going to happen as a part of the individual objects. So I could create the cursor ahead of time, or I could just create a cursor each time. So I'm going to do the cursor each time just to make this a little cleaner to read what's going on. So we'll create our insert transaction method. Now here, this needs the transaction object, but the transaction object is in main, but we're pulling from data. So we're going to need to refactor this and move this transaction class to somewhere where both of them can get to it. So I'm going to simply take this class, and I'm going to move it into the data file, so that both of these have access to the transaction class. All right, that's also going to break the test, but I'll come back to that in a moment. So now that we've got that transaction, I'll say self transaction is a transaction object, and this is none. All right, so let's head back to main. So we're going to create our cursor. So this line goes away. We will simply execute our query. Let's pull these in, insert into transactions. Here's our values, transaction. That all looks correct. So that goes away. This for loop we don't need because we have that up top. And now we need our dispose. So the dispose, let's go ahead and just create a close method. Oh, connection commit. We do want to commit on each one of these. Oh, actually, let me think about this for a moment. So the commit, we were doing this in each one. So we were actually doing this for the whole batch. And we're going to commit the whole thing. I actually want to keep that. So instead of creating this cursor in each one, I'm going to create it here. So self.cursor equals self.connection.cursor. So I'm going to change what I was doing, and we will implement these directly each time. All right, so self.cursor. And now here, we don't want just close. We actually want to commit. So at the end of it, we'll say database.commit. So that'll make sure that if there's any errors, that it rolls everything back. Otherwise, it'll commit everything. So let's create our commit. And this will just be self_connection.commit. That's it. We're just passing that straight in. Now that we've got that, now we need to just close everything out. Here's where we do our close. So we'll create a close method. And we'll say self_cursor close, self_connection close. But we're using this in a context manager. So what we really want is enter. And we're going to pass. We're not going to do anything on enter. But the exit, on the other hand, we'll call self.close. So we'll just close there. And now we can get rid of all of this code. All right, so that looks to be about right. Let's, okay, so commit. Close, none, none, none. Oh, interesting. I don't think I have to return this, do I? No. Oh, with the enter, this needs to be, I think that needs to be database. Now commits there. Okay, so enter needs to be the object that we're actually returning, not the constructor. Okay, so enter needs to say, here's the object we're returning. Exit doesn't do anything. There's our commit. That looks correct. All right, so now that we've got all that up and running, let's run our test. Let's see if we get the same results or if we have something new happening. All right, so we do have an error. Let's see. Exit takes one positional argument, but 4 were given. All right, let me do, I can't remember the exact syntax. Python. I'm not using these, but let's go and declare them. traceback. All right, let's try that again. All right, so we have an error that we aren't finding any records. That's probably to be expected. I'm changing some code here. Is that to be expected? Actually, it shouldn't be expected. It should pass the same way as we did before. So let's see what we've got here. None type is no attribute insert transaction. Well, it would help if return self. Let's try that again. There we go. Now we're passing. All right. So we've basically refactored the code. We've set up a facade. So our facade is this database class. It is hiding the fact that we're using MySQL. In fact, MySQL connector. Oh, that's in the test. So MySQL connector here is not used, so we can delete that. So we've now hidden the fact that we're using that class, so it is a good facade. Database now encapsulate all that for us. So let's head back into the transaction. So yeah, we can import transaction from main. Technically, transactions in another file, so let's do that really fast. Import transaction, and that will clean up our imports in main. Let's rerun our test. Excellent, we're still passing. So that's the facade pattern for the database side of things. So now let's switch back. What we want to do is a strategy pattern for the file-based interaction. So the file-based interaction, let's look and see where that's happening. So our CSV file path, we're using it in two places. We're using it for the read CSV file, and we're using it for removing the file, deleting the file. So we need to replace both. So what we'll do is we'll create some sort of object that interacts with the file. So let's create a CSV, let's create a file interactor equals CSV file interactor dot create. So I'll create a static method that's going to create one of these. We're going to give it the CSV file path. So that'll create our CSV file interactor. And now instead of passing the file path, we're going to pass the file interactor. And then here, we'll say file interactor dot delete file. So we're going to delegate these out. Our strategy is to use this class. So it's going to do both the delete file and the actual reading of the file. So let's head in here. This is no longer a CSV file path. This is a file interactor. And so here what we were doing is we were saying with open, read all the lines. We're going to change that. We're going to basically say lines equals file interactor dot read all lines. So this goes away, and now we unindent, and now we're running through. So this is the code that we're replacing, and we're going to replace it with just a single call. This code is going to go into a class, so it's not going to delete. That's why I'm only commenting it out for the moment, but that is going to clean up what we were doing before. We're going to move it inside our strategy pattern. So now that we have this, we need to also create this. So let's go ahead and create a new module, new file. Well, this will be file interactors. Let's just call it files. Let's make it really simple. So in files, we're going to create our class, CSV file interactor. And this is going to be an abstract class. So we'll say derives from ABC. Let's pass for the moment. We'll come back to this in just a moment. Let's do our import here so we get those. OS is probably going to go away, so that'll clean that up. So we'll say from main.files, we will import CSV file interactor. All right, so that's going to start cleaning up some of this. Read all lines doesn't exist. Let's go and define that. So we'll say def, and this is going to be an abstract method. So def read all lines. This will return a list of string. And we can pass, we can throw an error. I'm going to actually throw an error. Which one? Let's just raise an exception. Not implemented. So we'll do this as an exception so that in case it doesn't work, we will actually get a forced exception. So there's our read all lines. Now, in addition to that, we're also going to need the delete file method. So let's go ahead and create that method. And this will return none. It just does something. And again, we will raise our exception. All right, so that's looking good. The last thing we need is a create method for the main file to actually work. So this will be a static method. And create is going to return a CSV file interactor. And what this is going to do is it's going to return a file-based version of it. So we'll return a new file-based CSV file interactor. given CSV file path. All right, so this class does not exist. We need to create this class. And this will derive from CSV file interactor. It's going to need our constructor, so let's go ahead and define that. Self, and this is going to be the file path as a string. Let's hold on to that. And now here we need to implement our methods. So we'll say delete file, which is none. What are we doing in delete file? We're doing exactly what we were doing before, os.remove. We'll say self.file path. Oh, I am missing self on these. And we're going to need to import os. So there's delete file. Now we need, so I'm going to go and delete this line now. Now we're going to need the read files, so the read lines. So let's implement that now. Def read all lines. And this is simply going to pull these values in. Lines, return lines. So again, it's the same code as we had before. We're simply moving it to a new place. So self, file path, mode is read, new line. All right, there we go. So that is all looking good. We can now delete this code. And I think we're in good shape. Everything looks to be about right. Let's run this and see if we have a problem. And it passed. So we've now refactored the code. We've added our branching points. So in data, we've got a facade. In files, we have a strategy pattern. Let's head back. We have done our refactor. We're now ready to add a test that shows the ideal state. To do that, we need to head back to our test file. And we want to create a new test method. Let me give us some room so we can work. We're going to create a new test method that's not going to look very similar to what we had before. This is going to be a completely different method. So we'll say test transaction loading successful. So we're going to abbreviate this a little bit so that it's the normal. Eventually, we may want this test to just go away, or at least retire, be commented out or not used all the time. This would be something that's useful maybe once in a while, but we don't want to call this later on. This is just there to make sure that all the connectivity is working. But the most of the logic we're going to do through these abstraction layers that we're creating. So from here, what do we need to do? We need to create our in-memory database. So we're going to intercept, and instead of going to the real database, we'll do an in-memory database. And then we'll also do the same thing for our file system. So instead of going to the regular file system, we'll create an in-memory version. We'll need to clean those up at the end, and then we'll still need our assertions as we typically would. So let's write this out. So we'll say in-memory database provider equals new in-memory database provider. I don't think we need to pass anything to it. And let's do this with the with context because we need it to go away when we're done. So let's close that out. So what we'll do is we'll say with as in-memory database provider. So now we're going to need to do our in-memory file provider. And we're going to do the same kind of thing. So we'll say with in-memory CSV file interactor provider. So we're providing an in-memory version of the CSV file interactor class. Now to this, we are going to need to tell it what the file contents are. So let's do that. So we'll say example files dot, let's say normal file contents. So we're going to need to give it the file contents to serve up. And we'll say is as in memory CSV file interactor provider. Whew, that was a lot. Okay, so now that we've created those objects, we're ready to call into main. Now the dispose is going to happen automatically. So all we need to do now is our assertions. I could do that here, but I can also delegate these out to these providers. These are going to be test classes. So let's do that. So we'll say in-memory database provider. And we'll say assert transactions count. That there's 3. So we're going to do the same 3 assertions, and then we'll do the same thing in-memory CSV file interactor actor provider. We'll say, oops, close my backup, delete file. Assert file was deleted. That's basically the code. That's all we're going to have as a part of this test now. It's a lot cleaner, a lot simpler in terms of what we're doing. So we're creating our mocks, we're creating our in-memory objects. Then once we're done with that, we'll call into main, and then we will do our assertions. So let's start creating these again like we did before. I want to do these, do as much code as possible inside the testing code. So inside the test folder, let's create a new module, new file. We'll call it test framework.py. And in here, we'll create these classes. So we'll create a class in-memory database provider and in-memory CSV file interactor provider. we'll pass on those. Let's go and import these.
All right, what is it complaining about? Let's just try. There we go. Okay. So from test framework, we're going to import these two. We'll also do the same thing on example files. Now, example files, I can make an object, or I could make it a dictionary. I can make it a class. I'm going to just do this as a class that'll have a static property. Is that what I want to do here? Let's change this to a method just so it reads a little more naturally. So we'll create this as a class that has a static method that'll get us these contents. So let's do that. So we'll say class example files, and this will be static method. Def get normal file contents. This will return a string. We're not going to do anything for the moment. So example files, we'll need to import this as well. Now that's not the only way I could have done that. I could have done this as an object. I could have done this as a property here. So there's a few different ways you can declare what we're doing here, but this seems about right for me. So I'm just going to go ahead and do it this way. So we'll create a class called example files that has a static method for getting the file contents. Now we need our assert transactions count. This will be inside the database. So let's go ahead and define this. So self and expected count. And then do the same thing. Make sure that pulls up. And we'll need our enter and our exit. Let's just go ahead and return self. I know what we're going to do there, so let's just implement that. And then exit. And I'm going to pull from what we already did. This was in the database. We'll pass. We'll come back. We will do something different. We're going to do the same thing on these other ones. So let me copy these. This will be an in-memory CSV file interactor provider. And return self. None there. And then... So we're done with data. We're not done. We're going to come back, but that's okay. So we'll assert file was deleted, so we'll add this method. Self, nothing else, and then this will be none and pass. All right, so we've got our method declaration set up. Our test file looks good, so I'm just going to hover and make sure that I didn't miss anything. Everything is resolving to the type hinting. I think we're in good shape. So now we're ready to start implementing. Let's head back to test framework. We'll start with... why don't we just do the example files first? Get that one out of the way. That one's pretty simple. Let me open up the optimal one. And I'm just going to copy this, and we will simply return that out. So that's it. That's all we're doing is returning the content straight out. That one's done. That one's easy. So now I've got the contents inside as a variable, and I can run through and do whatever it is I need to do with the regular code. So now let's move on. Let's do the database first. So the database, if you recall, we were using a facade pattern. So in the facade pattern, what we need to do is we need to go to the facade and we need to tell it, hey, instead of doing what you normally do, here's what I want you to do instead. So we're going to give it the forking logic inside the facade pattern. So inside here, let's go ahead and define a constructor. I say that, let's think about this for a second. So we'll need to do on enter. On enter, we could reset everything and set up the interaction. On exit, we could return that interaction. So let's do that. So we'll basically on enter, let's reset our transactions. So we'll create an in-memory table, also called a list, that represents the transactions that we're going to be using. And then we need to set up the intercept. So what we're going to do is we're going to go to the database class, and we're going to tell it override the insert transaction behavior. And instead of doing what you're normally going to do, I want you to do a function instead. So I'm going to do a lambda. We're going to say a lambda given a transaction. I want to say self.transactions.append transaction. I'm simply going to hold on to it in myself. So I am the in-memory database provider. Then when we're done on exit, what we're going to do is we're going to go back to that and we're going to say reset override insert transaction. Stop doing what you were doing. I'm no longer intercepting. We are now undoing what we were doing there. That's basically it for this. Now let's go ahead and do the assertion and we'll move to the database class. The assertion is simply going to be if self transactions, and we need the length of that, is not equal to expected count, then we will raise an exception. Let's do an f string and say expected count transaction. Let's do, so we expected blank transaction, but found. And since we're doing this twice, let's go ahead and say, so actual length, actual count equals length of self transactions. So we're using it twice, so I don't want to do that in both times. Actual count, there we go. So there's our assertion. So now we're ready to set up the database class. Let's head back into the data file that I closed earlier. So we'll head back in. We need to implement these methods. So we'll have override insert transaction. These are both going to be static methods. And this is going to take the behavior. So we'll say insert transaction behavior, which is, okay, I think it's callable of transaction. See if I can remember the syntax. I don't remember the syntax, and that's okay. I'm just going to leave it alone for the moment. But this is basically going to be a call. It's going to be a function or a lambda. This will return none, and we'll hold on to what we need to do. Let's go and do the reset override. Also none. And reset is going to be simple. It's simply going to call into the override insert transaction. So we'll say, let's see. And we'll pass none. So we'll just pass straight into the other method. So this one, what we're going to do is we're going to hold on to that. So we'll say database dot insert transaction behavior override equals that. So now let's create this. Do I want to do this as a static field? I'm not going to do this on database. We'll simply create this as a global. I think that'll be a little cleaner. All right, so now we're going to set that up. So now that we have that defined, now we're ready to use it. And basically what we want to do is, if this thing exists, we want to use that instead of what we normally want to do. So inside here, anywhere where I would normally call into the database, I'm going to not do that. So we'll say if insert transaction is not none, then we'll do these lines. If it is none, we do nothing. So I'm going to reverse this. I'm going to do this as a guard clause. So if it is none, we'll simply return. So a guard clause is just an if statement that short circuits out of whatever function we're in. So if it is none, actually that's not true. If it's not none, we're going to return out. If it is none, that means we want to do our normal behavior. And so we'll run through that way. So if the transaction override behavior exists, if it exists, then we exit out because we're going to ignore that. We don't need to do anything on self. On close, we do. So again, if insert transaction behavior override is not none, we will return. We will exit out. Otherwise, we'll close. Actually, we don't even need to do that there. We can just move that inside the close method. That would be cleaner. Now that we've got that, we need to figure out and commit. So commit, we're not going to do anything. So we'll do the same thing if it's defined. So we'll just simply guard clause. And then finally, the insert transaction. This one's the most interesting. We don't just do that. We're also going to actually invoke it. So we're going to call the method and introduce it. And say, do whatever it is you want to do, and then I'll return. Otherwise, I'll basically exit out. So that is the functionality for the facade. So again, we've set up the branching points using if logic to say, if this behavior exists, don't do what we would normally do something else, which really the only time we do that is inside the insert itself. Everything else just ignores the connection. This way it won't create a connection, it won't close the connection, it won't commit the connection. None of that is going to happen if this override behavior exists. So that basically sets up the database. Let's run this. Now, it is going to fail, so we're not going to really get anything passing, but let's go and run. Okay, so I do have in-memory CSV file interactor provider. Oh, okay, so my file interactor provider, I need to set up a constructor. Self, and this is going to be the file contents string. All right, so I did forget that constructor. Let's run this again. All right, so we are back to, it's actually connecting to the database itself or the file, and we're not getting what we wanted. So that's pretty good. This won't really work until I get everything up and running. So let's go ahead and move on to the file interactor now. So the file interactor provider, what we're going to do is we want to set up a new file interactor provider or file interactor that derives from the other one. So from here, we also need to import. So from main.files, we will import CSV file interactor, and we're going to create an in-memory version of that. So class in-memory CSV file interactor, which derives from CSV file interactor. And then this class, we had a couple of methods we needed to implement. I'm just going to copy this over from here. We don't want to do what we were doing here. What we're going to do instead is, let's implement this really fast. So self.wasFileDeleted equals true. And we can initialize that to false. So let's go ahead and do that. So it was false. When it's deleted, it's true. The read all lines, this needs to get the value. So we're going to need in the constructor, we're also going to need the file contents. And hold on to that. And here, we just need to return that. So self, file contents, and we want to split on new line, which I believe, we'll test this. It may just be \n, but let's do \r/n, which is the Windows new line. I don't remember the way Python files store the file separators. So let's run through that. That's basically it there. So let's go ahead and set this up now. So the in-memory CSV file interactor provider, we're going to need to create one of these. So we'll say self in-memory file in-memory CSV file interactor equals new in-memory CSV file interactor. We're going to give it the file contents. Now that we have that in self, we want to set up the strategy. So we want to use this strategy instead of the other one. So let's go ahead and set that up. So what we'll do is go to the CSV file interactor class and say set initializer, that instead of doing what you normally do with a file path, what I want you to do instead is one of these. So this is going to be self in-memory CSV file interactor. So use my file interactor instead of what you would normally do. I believe we can discard file path. We don't need it for this. Then on the exit, we're going to undo that. So we'll say CSV file interactor reset initializer. Finally, we'll set up the assertion. This is going to be effectively delegating out. So self in-memory CSV file interactor was, well, let's just delegate it completely. So we'll say self in-memory assert file was deleted. So we're just going to delegate straight out to the other class here. And we'll do our check. So if, let's see, if self was file deleted not equal true, we will raise our exception. File was not deleted. So that basically sets up everything that we're going to use for this file. So now we're ready to get into the CSV file interactor to tell it to use our version of the in-memory version rather than what it normally does, which is the file-based one. So we need to create these two methods, set initializer and reset initializer. Let's go ahead and set those up. So CSV file interactor, these are going to be two new static methods. And this needs the lambda, so this is going to be the initializer. And again, since I don't remember exactly how to do the callable syntax, I'm just going to ignore that for now. So there's our initializer. And then we'll need another one. That'll be reset initializer. All this one's going to do is call set initializer with none. All this one's going to do is hold on to it inside, and I'll again do a global field. So we'll say global initializer. Let's do CSV file interactor initializer. So that way, if I have multiple initializers, I know which one it is. We'll set that equal to initializer. So let's go ahead and create. And now we're ready to use it. Now that we've got that set up, what I want to do is do a check on that. So on create, we'll say if is not none, then we will invoke that. Otherwise, we'll do our regular file-based CSV file interactor. That's effectively it. Let's look at everything. I think we're in good shape. Let's run the test and see if I've got any problems. All right, so I do have a problem. Let's see what we've got. We expected 3 transactions, but we found 1. I think this is the new line problem. So I think the new lines are not what I thought they were going to be. So let's do, I'm going to set a breakpoint here. I'm going to debug the test and see what the value is coming in as. \n. So it's just a single \n. All right, so let's change that. So the file, so when I pasted it in, it changed it to \n. Let's rerun our test again. And we're passing, and passing fairly quickly. So we have all the code set up and ready to go. That all looks correct. So let's do all of the tests. They all run, they all pass. Let's head back. We've now created the code to make the test pass. Let's do a cleanup, and then we'll check in, and then we'll move on to the last step. So now that we've got all this up and running, let's look and see if there's anything I want to clean up here. I think this all looks good. Excellent. So let's close that. Let's go to the data. I want to move this up now. Put this into global fields, paste that there. So there's our transaction class. That's obvious. Database. All right, I think this all looks good. Let's go and close data for now. Test framework, let's check what we've got. In memory, let's go ahead and kill our breakpoint. This all looks good. I don't see anything I want to change there. And then testing framework, this is all definitely looking good. I just want to make sure there's nothing I want to delete. That looks good. And main, same thing. We can get rid of import OS, so let's go ahead and clean that up. All right, this all looks good. Let's run our test again. Everything's still passing. Let's go ahead and do a commit. Created a test that is the model for testing going forward for verifying transaction loading. All right, stage everything and commit. That takes us through our refactor. We now want to add a failing test representing a bug, and then we'll fix that code. These are going to go fairly quickly. Now that we have the ideal state, it's going to be pretty simple to copy and paste our test and change to what we want it to do. So let's go ahead and we're going to copy our test. We're going to paste it straight down. And this will be, instead of being successful, this will be with header row. So we're going to do the one that has a header row. It's example file 2. This one we do expect to fail. So let's say get with header row contents. File contents. So we'll make it so this is get normal file contents. This is get with header row file contents. And we're going to expect it to still be 3 records. And I know that because there's the 3 records. So let's go ahead and create this really fast. So let's head back to the example files class, and we'll create a new method, also static, def, copy, paste, there we go, return, and let's head back into our file. Let's copy the contents. There's our header row. We can go ahead and close this file now. All right, so now we are ready to see if we can make the test fail, and it does. So we expected 3, but it found 0. And chances are it found 0 because it couldn't even parse that first record, that first line. So we do have the error that we were expecting in production. So now we're ready to get it to be fixed. So we've already moved on to fix the bug in the code. Let's head into main. There's a few different ways to do this and a few different places I could do this. I'm going to do this in our read CSV lines up here. Okay, read CSV file. So here's our lines. I'm going to do this right here. I'm going to basically say, okay, let's look at the lines. If the first line is not what we want, if it's a header line, then we're going to eject it. We're going to get rid of it. And we're going to remove that line. So again, there's a few different ways to do this. And what we'd probably want to do is talk with our business people and our users to understand a few things. Is the header row, does it always have these values? If it doesn't have these values, are there other values? What are the ways that we can detect that it's a header row? I could just say if the first row fails on the import, then I ignore that row. So lots of different ways to code this up. I'm going to do this simply. I'm going to say that we talked to people and they said, yep, every time they send it, they always send it with this header row. It's exactly these values. Great. That makes it really, really simple. All I have to do is say if lines 0 is that, then we're going to simply remove that line. Not remove from the end. Is there a way? So is there a slice or a splice? I can't remember how to do this in Python. Oh, so this would just be the actual value. Let me see if there's a way to do this in Python. Let's see, Python list remove at index. Oh, of course, the substring or the indexer. So this could just be lines equal lines and then 1 colon. So we're going to start at 1 and then we'll go through everything. I believe that's all we need to do. That's to get the sub list. I think that works. Let's just run it and see. There it is. All right, perfect. So we've now removed the first line if it happens to be that. Let's run all the tests. Everything still passes. So the original test that we had still passes. The new test we had, which has the full file contents, passes. And the new test that gets rid of the header row, if it exists, also still passes. So now that we've done that, we'll do one more cleanup, which really we don't need to do. Everything was pretty simple. I will do this. Let's go ahead and create a little space around these. And we'll say, if there is a header row, delete it. We could even move that to another function if we wanted to help clean everything up. But that looks really good. Main is good. Test framework, we don't need to do anything there. That looks good. Transaction loading, we've got our test. That looks good. We're set. Let's go ahead and do our final commit. How easy that was. Fixed a bug where a file with a header row caused an error. So much easier to fix bugs when we have a testing safety net that shows us exactly what we're trying to do. That concludes the Gold Belt Kata. Just to review one more time, a lot of different things going on here. The way I did it is not the only way to do it. You can use whatever pattern and approach makes sense. I would probably use strategy pattern everywhere, but the goal is to go through this process, go through these steps. So this is a way to do that.